Hello friends, this is Dr. Sangeeta Joshi from Vidyalankar Institute of Technology, Mumbai. Currently we are studying the course Fundamentals of Logic Circuits. It's a lab course. Today we'll try to understand verification of multiplexer operation using LTspice. Before we start, let us try to understand what is the meaning of multiplexer. Multiplexer simple definition is many inputs and single output. Now for example here I have shown two inputs and single output. And of course, the basic definition is that one of the inputs is selected and that is one of the data is selected, input data, and that is made available at the output or that is routed at the output. Now, which one is to be selected? That is based on the select line, based on the signal on the select line. If S is equal to 0 here, then A would be selected and made available connected to the output. If S is equal to 1, B would be selected and it is made available at the output. Now there are various ways by which it is titled as a multiplexer. For example, one of two, sometimes people call one of two multiplexer, sometimes they call 2 as to 1 multiplexer, or maybe 2 cross, that is multiplied by 1 multiplexer. Okay, so let us try to understand the truth table. What does it mean? Now I have already told you, as long as the S is equal to 0, whatever is the data on the A 0101, that is connected to the output. So 0101. So you will get the same output as that of the A. And whenever S is equal to 1, you will get the output 0011, which is nothing but the data on the input B. So input B would be selected 0011 for making the data available at the output. Now, similarly, let us try to understand higher number of input multiplexers. 2 as to 1 already we have seen. Now, what is this? 4 as to 1. So, there are 4 inputs and 2 select lines. So, one of the inputs based on the number of select line, status on the select lines would be selected. If it is 00, A would be selected. If it is 01, B would be selected, and so on. And you will find everywhere that enable line is there. Enable. So this is nothing but for selecting this IC or activating, making this IC activated or circuit activated. Okay. Now let us understand 8 as to 1 multiplexer. So there are 8 inputs here, A0 to A7. So based on the status of the select lines, S0, S1, S2, here actually it is S1 and S2. So based on that status, one of the inputs is selected and that is made available at the output. Okay. And to generalize multiplexer this definition in terms of number of inputs, 2 raised to n as to 1. So there are 2 raised to n inputs and one output. But how many select lines are required for 2 raised to n inputs? There are n selector lines required. So whenever n is the number of select lines, 2 raised to n inputs can be possible. So for 4 number of select lines, 2 raised to 4 is 16. So 16 would be possible. So this is how we can make generalize the multiplexer diagram. Now logic circuit of 2 as to 1 multiplexer. Now in the logic circuit, basically it is comprising for each of the input, you will require a AND gate. Here also you require for B input AND gate. Now select line, how it is connected to these AND gates. Here is only one select line and this inverter plays an important role. Because of this inverter, whenever S is equal to 0, here 1 is 0 inverted to 1. So then whenever one of the inputs to the AND gate is 1, whatever is the other input that is made available at the output. That means whenever I am putting here 1, if A is equal to 0, 0 is here because 1 into 0 is 0. If A is equal to 1, 1 into 1 is 1. So whatever is the status of A, that would be made available here. And since here S is equal to 0, B information will not be passed at this point because 0 means always you will be getting a 0. So one of the inputs to the OR gate is always 0. The other input is the whatever is the data that is available at the A. So A is as it is passed on here. So A plus this 0, anything added to the 0 is that thing is itself. So Y is equal to here nothing but the A whenever S is equal to 0. Whenever S is equal to 1, this is 0. So this is not activating and B is 1. S is equal to 1 and whatever is the data on the B, either 0 or 1, that is passed on to the output of the AND gate. So here to the OR gate B data is available and since here it is 0, whatever is the data at the other input, that is this that is the B information is made available. It is simply passing the information from the input to the output. We are not changing the information. We are simply passing the information. So here in short, we can write a Boolean expression for multiplexer. Y is equal to, this is actually A S bar. This bar has to be, I can make the changes. This bar actually has to be, it has to be here. So this bar is, okay. So this is actually, sorry, this bar is actually A S bar. So A into S bar plus B into S is as it is taken. So B into S. So again it is shown in this fashion. You will find that whenever S is equal to 0, input A is selected at the output. Whenever S is equal to 1, input B is selected at the output. Now, for the 4s to 1 multiplexer, again you require the whatever number of inputs, so many AND gates. So 1, 2, 3, 4 AND gates, I0, I1, I2, I3. This is the data that is to be routed at the output. So we are interested in passing this data or information at the output. There are 4 inputs. But which AND gate is to be selected is based on this structure or this network, S0 and S1. Now, for example, whenever S0 and S1 is 0, 0. So because of this inverter, it is 1 and here also it is 1. So whenever these two inputs are 1, 1, then only this AND gate is selected and this information is passed on to the input to the OR gate. So mind you, at a time only one of the AND gates would be selected, either this or this based on the status of the S0 and S1. So here is the truth table. Whenever it is 0, 0, I0 is made available at the Y. Whenever it is 0, 1, I1 is made available at the Y1, at the Y output Y, and so on. And how to write a Boolean expression based on this truth table? You can see here Y is equal to, you take first combination 0, 0. That means S1 bar, S0 bar. So S1 bar, S0 bar and into I0. So that is how this AND gate is required. So this AND gate is nothing but this expression. Then what is the second AND gate? S0 and S1 bar. So this is S0 and S1 bar into I1. So this is the second AND gate. Then S1 into S0 bar, S1 into S0 bar into I2. This is the third AND gate and this is the fourth AND gate. And then this plus sign, it is nothing but one OR gate is required at the output, and that is how this circuit is. Now let us try to see. I have already given you many assignments and lab work related to LTspice. So you know how to draw schematic in a LTspice. So this is the schematic which I have just discussed with you for the 2:1 multiplexer. So two AND gates we have taken, one OR gate, one inverter, and we have included the 74HCT.lib, and I have given 1 microsecond and 2 microsecond time period for this A. That means total period is 2 microsecond. Slightly higher I have taken 20 microsecond, and cycle of 200 microsecond I have taken at a S. S I have taken larger time because then only it would be possible for us to see the waveforms. I'll also show the results directly, and then I'll move to the LTspice. So you can see here, this is my input A, this is my input B. So this is 2 microsecond period, this is the 20 microsecond period. You can see here, this is the 20 microsecond period. And this is my select line. In the beginning, my select line is 0, right? So when my select line is 0, I should get at the output. This is the output Y. Which one I should get? I should get input A. And you can see this frequency. This frequency is, that means the same input A is made available at the output. But to what extent? As long as the S is equal to 0. Here I will find that my S is again going to be 1. So now multiplexer has changed its path from A to B. Now it is not selecting A, but it is now selecting B, because now S is equal to 1. So B, this frequency is available with the B. So this waveform is now, you can see the same waveform is available here. And that is how we have verified the operation of the 2:1 multiplexer. Thank you.